Welcome back, everyone. Mr. Allen here. I'm going to quickly try to go through an explanation of the Monty Hall problem here. I've seen a lot of different tree diagrams out there on the internet, and I think that sometimes they're a little bit more complex than they need to be. So I'm going to break this into two parts, basically two tree diagrams, and see if it helps. So I'm not going to explain the Monty Hall problem here. If you're here, assumedly you understand the problem, but you can kind of go look for it if not. So the first thing I'm interested in is sort of just getting started. When I make my guess from the start, again, it doesn't matter whether it's door 1, 2, or 3, I have a 1 in 3 chance of having chosen the door that has the car behind it. And I have a 2 out of 3 chance, or 2/3 chance, that I've chosen one of the doors that has a goat behind it. So what we want to do then is look at what is the result of switching or not switching. And I'm going to keep them separate because I think it, again, helps clear things up. If I don't switch, then pretty straightforward. If I'd had the car from the start and I do not switch, I win. If I had chosen either of the goats from the start and I do not switch, I lose. So without even worrying about sort of my other option here, it's just sort of when I don't switch, 1/3 of the time I've guessed correctly from the start and I end up winning. 2/3 of the time I've guessed incorrectly from the start and I end up losing. So we can simply say that we win 1/3 of the time when we don't switch. Now, exact same problem when we switch. From the start, of course, exactly the same situation. 1/3 of the time I will have, just by luck alone, chosen the door that has the car behind it, and 2/3 of the time I would have chosen one of the doors that had a goat behind it. Now what happens if I switch? Well, I'm losing the 1 time out of 3 that I actually had the car from the start, and I'm winning 2 out of 3 times because that's how likely I was to have had a goat from the start. And so pretty straightforward again. We're going to win 2/3 of the time when we switch. So without doing too much else, we just looked at the situations, don't put them all together, but break them apart, switching versus non-switching. Switching allows me to win 2/3 of the time. Not switching allows me to win only 1/3 of the time. Another way to think about this is if I were given the choice of the 3 doors from the start and I chose door 1, and then Monty Hall offered me the option to switch to both of the other doors instead of the one that I had chosen. So I chose one, I can keep the one, or I can get doors 2 and 3 both in order to try to win the car. Obviously, in that case, I want to make the switch. Well, essentially, that's what he's done anyways. I choose my door 1, he opens one of doors 2 or 3, but in essence, he's giving me the option to choose the door that he's opening and showing me, as well as the door that he's keeping closed out of those 2 options. So he's giving me both of the other doors instead of the door 1. And so obviously then I've improved my chances 2 out of 3. Even if I know one of those doors is bad, I knew that from the start because there's only one car. So guaranteed one of those 2 doors was bad from the start. But now I've got door 1 or I've got the door 2, 3 combination. And obviously that's twice as many opportunities to win, and I should make the switch. And for the record, the Monty Hall problem as described is not correct. Monty Hall did not allow you to switch your choice and choose to have a second shot at the car. What he did was he opted to, or gave you the option to opt out of playing the game by paying you off. So it wasn't a, do you want to switch, yes or no, you win the car if it's behind the last remaining door. It's, I'll give you $1,000 if you want to quit now and leave, as opposed to making the switch. Just because, of course, they had figured out, either through trial and error or through actual math, that the probability of switching increased the person's chance of winning far too much.